This video goes over adding and subtracting rational expressions. Some of our denominators this time around are going to be binomials, so it's a little bit trickier to find the common denominator. So in the first one, I'm looking at my denominators here. I've got 5b and 15a. To create my common denominator, I want to make the numbers the same. So I can see that I have to multiply my first one by 3 so that my 5 is going to turn into a 15. When I take a look at the variables that I'm missing on both, I notice that I need an a and a b to make my denominator common. So in my first fraction, I'm missing an a from my denominator, so I'm going to multiply the top and the bottom by a. In my second one, I'm missing a b, so I'm going to multiply the top and the bottom by b. Expanding that out gives me 6a squared minus ab minus 2b all over 15ab, making sure that subtraction sign applies to both of those terms inside that bracket on the right hand side. That's as far as I can go. So the next thing I'm going to do is state my restrictions. So I'm looking at the numbers that cause a problem for my denominator. So a can't equal 0 and b can't equal 0. Okay. Moving on to my next example here, I've got x minus 2 on the bottom of my first fraction, and I've got x minus 1 on the bottom of my second fraction. I can find a common denominator the same way I did with just numbers by multiplying those two together. So in my first example, I am missing the factor x minus 1 on the bottom. So I am going to multiply the top and the bottom by x minus 1. On my second fraction, I'm missing x minus 2 on the bottom. So I'm going to multiply the top and the bottom by x minus 2. So now my denominators are the same. And if you notice, I can cancel out the x minus 1. I'm not going to do that. That would defeat the purpose of creating that common denominator. So then on my numerator, I've got x plus 5 times x plus 1 plus x minus 3 times x minus 2 all over x minus 1, x minus 2. I should simplify my numerator a little bit by expanding and collecting like terms. So I'm going to get x squared, minus plus 4x minus 5. And then on the right part, I've got x squared. Minus 2x minus 3x would give me minus 5x plus 6 all over x minus 1, x minus 2. And then I'm going to collect like terms, which gives me x squared minus x. And then, minus 5 plus 6 is plus 1. Oh, and I've got 2x squared here. Okay. I can't factor that any further, so now I just need to state my restrictions, which are the values that make the denominator equal to 0. So that would be x can't equal 1 or 2. In example C, now I've got a binomial and a whole number, so I can see that the only thing I'm missing from my denominator is an extra a minus 3 on the right hand side. So my common denominator is just a minus 3. So that means I'm left with, on the top, 3 minus 6 times a minus 3 all over a minus 3. And then I can expand and simplify the top just like I did in example B. So 3 minus 6a plus 18 all over a minus 3, which is going to give me 21 minus 6a over a minus 3, which I can common factor on the top. So I can common factor out of 3, gives me 7 minus 2a all over a minus 3. The last thing I need to do here is to state my restrictions, which are the values that cause the denominator to be equal to 0. In this case, I just have a can't equal 3. here I've got another two examples, a little bit more complicated factoring in order for me to create the common denominator, or I have to factor first before I can create the common denominator. So let's take a look at D. My first fraction, all I can do is common factor out a 2. In my second fraction, I've got a difference of squares on the bottom, so I can rewrite that as x over x minus 3, x plus 3. Looking for a common denominator, I'm going to essentially multiply those two together. So I've got a 2, so I'm missing a 2 for my right-hand side. The only other thing that I'm missing is an x plus 3, because both of those denominators already have an x minus 3. So if I multiply my left-hand fraction by x plus 3 and x plus 3, and then my right-hand fraction by 2 over 2, now I'm going to end up with x plus 3 minus 2x, and both of those are over 2x minus 3 times x plus 3. And then we've got x minus 3, x plus 3 times 2 as the denominator for my second fraction. So here I've got another example of creating a common denominator. So now all I need to do on the top is collect like terms. So I'm going to get 3 minus x over 2 times x minus 3 times x plus 3. I'm going to do the factoring out a negative trick on the top. So I can change this to x minus 3 on the top, which is going to allow me to cancel out a factor of x minus 3, leaving me with minus 1 over 2 times x plus 3. The last thing I need to do is state my restrictions. So those are the values that make the denominator negative. So in this case, x can't equal negative 3 or positive 3 from the factor that I canceled out before. Last example here. Just like example D, the first thing that I'm going to do is factor the denominator. So here I can factor my simple trinomial as x minus 5, x plus 3. My second factor, I can common factor out an x. And what I'm going to notice is that I actually want my 5 minus x factor on the right-hand side to be x minus 5, so that it matches up with one of the factors I already have, which makes things a little bit easier when finding a common denominator. So I'm going to rewrite the first one here. And then what I'm going to do is I'm going to factor out a negative sign, which allows me to flip the sign of the terms that are in the brackets. So now my expression on the right, this line and this line are equivalent, but now I've got a matching factor on the denominator of my second fraction to the denominator of my first fraction. Okay. So let's do a couple more things here. I also notice that I've got two negative signs right here. So I'm going to rewrite those as one positive sign. And then I'm going to work towards creating my common denominator. So I notice that both of those denominators have an x minus 5. So I know that has to be part of my common denominator. I also have an x, and I also have an x plus 3. So when I multiply those three factors together, that's going to give me my common denominator. And now looking at my fractions, I'm going to figure out which one is missing so that I know which one to multiply by. So on my left, my first fraction, I am missing an x on the denominator. So I'm going to multiply the top and the bottom by x. On the right-hand side, I am missing an x plus 3. So I'm going to multiply the top and the bottom by x plus 3. Now my denominators are the same. Now I can add my numerators together and keep the denominator the same. So I've got x times x minus 5, x plus 3. Okay. Expanding and simplifying the top is going to be x squared plus 5x plus 3x plus 9. And then again, my denominator is still the same, x times x minus 5x plus 3. And my expression on the top is x squared plus 8x plus 9 over x times x minus 5x plus 3. I can't factor that top anymore because the only two numbers that are going to multiply to 9 are 1 or 9, or 3 or 3. Neither of those can be combined in a way to give positive 8 and multiply to positive 9. So last thing left here is to state my restrictions, which are the values that make the denominator equal to 0. So in this case, x can't equal minus 3, 0, or positive 5. The last thing that we're going to practice in this video is finding the lowest common multiple. So here we're really practicing finding the common denominator. So we're going to pretend that these two are our denominators, and we're going to try and figure out what would be common between them, the lowest common multiple, to make our life easy. So I'm going to start with the numbers. I'm going to write out the factors of 12, and then I'm going to start by writing out the factors of 15. So I can see that the first number they get to that's the same is 60. So I know that that has to be the number, the lowest common multiple for the number part. For the variables, I need to work my way up to the highest exponent for each particular variable. So for x, I have x to the 4 and x squared. So my lowest common multiple is x4. Here I've got a 5 and a 2 on the y, so my lowest common multiple would be y to the 5. I would get here by multiplying my first one by 5 and my second expression by 4x squared y cubed. Let's take a look at the second example. Here I've got 3 that I'm trying to compare. So I'm going to do the same thing. I'm going to look at the number first. I've got a 3, a 2, and a 1. The lowest common number, multiple between those numbers, is 6. Lowest common multiple for the m is going to be the m that has the highest exponent, which is m squared in this case. The lowest common multiple for the n variable is going to be the n that has the highest exponent, which in this case is n squared. So I would get there by multiplying my first one by 2n, my second term by 3m, and the last one I'd multiply by 6mn to get to my lowest common multiplier of 6m squared n squared. In our second lowest common multiple example, we're going to look at expressions that have more than one term. So in order to find the lowest common multiple, the first thing that you need to do is factor. So here I've got x minus 4. I can't factor that anymore, but I can factor my second one as x plus 6, x minus 4. Now what I notice is that I have two factors in my second expression and one factor in my first expression. Those x minus 4s are common. The only thing missing from my first expression would be x minus 6. So my lowest common multiple between these two would be x plus 6, x minus 4, and I would get there by multiplying my first one by x plus 6. Second one, I need to factor both expressions. So I've got y minus 3, y plus 3. And then I've got a perfect square trinomial here. So I would have y plus 3 all squared. So each expression has two factors. In the right-hand side, I'm missing y minus 3. And on my left-hand side, I'm missing an additional factor of y plus 3. So my lowest common multiple is going to be all three of those things together. I can get there by multiplying my expression on the left by y plus 3 and multiplying the expression on the right by y minus 3. Looking for what is missing and what is common helps you to find the lowest common multiple, just like the lowest common denominator. Technically here, this is another if I directly multiply those two expressions together, I would get y minus 3 cubed times y plus 3 cubed times y minus 3, which is another example of a common denominator, but it would not be the lowest. The same way, if you're adding a half plus a third plus a sixth, you could use a common denominator of, let's say, 18, but that's not your lowest common denominator, so you're going to need to simplify again afterwards. It is better to use your lowest common denominator of 6 in this case. Good luck with adding and subtracting rational expressions.